Hey everyone, welcome back. Welcome to our new unit, Unit 7, which is Solutions. This is Lesson 1, and today we're going to be talking about the properties of water. So in the last video, or last set of videos rather, we spent a lot of time talking about gases, the different gas laws, and all those things involved. But today we're starting a new unit talking about properties of water, a bunch of solution vocabulary, and slightly touch on table F, just kind of saying that it exists, and we're going to focus more on it in the next video. Anyway, here is the matter flow chart. This should be semi-familiar with you, or to you rather. We did this very early on in the year. So remember, matter is broken down into either pure substances or mixtures. Pure substances are two or more things, or just things that are chemically combined. With definite chemical compositions. Mixtures, two or more things, same place, same time, not chemically combined. And then your pure substance can either be an element or a compound. Mixtures can be homogeneous or heterogeneous. Remember, heterogeneous is non-uniform composition. So if you were to say, let's say here's a cup of water with some sand, if you sample from up top, sample from the bottom, you get different things. Homogeneous mixture means you have a uniform composition. So things are evenly spread out. So if you take a sample from the top, a sample from the bottom, you get the same thing. Now, solutions are a type of homogeneous mixture. And so we're going to spend time, this whole unit, talking specifically about solutions. And so a lot of solutions, they happen the way they do, or a lot of solutions have water involved. And based on the structure of water, we get these different types of properties and behaviors. And so all of these behaviors that we see really comes down to these hydrogen bonding. So remember, hydrogen bond, H bond, is not a bond, but rather it is an intermolecular force. So a hydrogen bond is really the interaction between the H of one molecule. Remember we said H bond is F, O, and fun. It's the interaction between the H of one thing and the F, O, or N of a different molecule. So in this picture of water, these green circles are actual bonds. These are our polar covalent bonds that hold the hold the H and the O together to form that water. But because of these polar bonds and the difference of electronegativity values, O is a little bit negative, H is a little bit positive. And so when they interact with each other, the positive wants to be near the kind of negative thing. And so this attraction, that dotted line, that is that hydrogen bond. Again, it's an attraction between the two molecules, not an actual bond. And so because of that strong attraction between the molecules, we get things like strong surface tension, low vapor pressure, or high boiling point. And that's why ice actually floats, because it is less dense than water. And we're going to spend some time going into all three of these things in more detail. So first, surface tension. Textbook definition is a property of a surface of a liquid that allows it to resist an external force. So in this picture, let's imagine we have some water. So here's a water molecule, like that. So you have 4 different water molecules. Now, they're arranged in a specific way, so the positives and the negatives are near each other. And so water molecules will arrange themselves in that specific way. And that hydrogen bond is strong enough to kind of let a little insect or something kind of not float on top, but just rest on top of the water. So what's keeping that bug afloat's the wrong word to say, what's keeping that bug on the surface is the strong hydrogen bonds. If you were to kind of stick your finger in this water and disrupt it, you would disrupt all of the molecules, the bug would then fall into the water. You can definitely try this at home. If you take a glass of water, so there's your water, and then if you put a little spring from like a pen on top, the spring is not floating, it's laying on top of the water because of the hydrogen bonds. As soon as you disrupt that surface of the water or touch the spring, it will sink. Then if you want to retry, you'd have to dry it all off perfectly again for it to work. But a great demo to show surface tension. Again, because of hydrogen bonding. Next is vapor pressure. And we're going to spend some time later on this unit talking about vapor pressure. But vapor pressure really basically is the pressure on a liquid to become a gas. So if you have low vapor pressure, things are happy, quote unquote, happy as a liquid. And if something is or has high vapor pressure, it really, really, really wants to be a gas. Really wants to be a gas. And again, not using very sciencey words right now. We'll get into this more later. But low vapor pressure, things are happy as a liquid. There's not much pressure to become a vapor. Remember, vapor is just another word for gas. If you have high vapor pressure, you have a lot of pressure to become a gas, and you really want to become that gas. So water has this low vapor pressure because of these strong intermolecular forces. So these water molecules, they like hanging out near other water molecules. So remember, if you have liquids, the particles are all kind of slowly sliding past each other. But if you're a gas, the particles are literally going crazy. But water molecules want to hang out with other water molecules. So if you tell the water molecule, hey, go be a gas now, go separate from your buddy, they're going to be like, nah, I don't want to. I want to be with my friend. And so that's why they have these very, very high boiling points. So with a high boiling point, it means you need a high temperature or a lot of heat energy to break those interactions apart and disperse the water molecules to form that water gas or water vapor. So the stronger the intermolecular force, the higher the boiling point, the lower the vapor pressure. And we're going to talk about this relationship a lot more later on. Next, water in a solid state. So again, if we look at how these molecules are arranged, remember solids, things are very slow, they kind of vibrate. We have slow moving particles that vibrate. And then in gases, we have very fast moving gas particles in this straight line motion. So as you cool it down, so here we are cooling, particles are moving slower and slower and slower. So in a solid, these slower moving gas molecules, as it's becoming that frozen block of ice, that frozen water, the particles arrange themselves so the partially positives are near the partially negatives, forming this kind of crystal structure. Now the mass of these are both the same. If we look at the density equation, the mass is staying the same, but now the solid water has a much bigger volume. So when you divide by a bigger number with mass staying the same, your density actually decreases. So yes, liquid water has a density of 1, but the density of ice is actually a little bit less than that, which makes it able to float. Okay, so moving on to kind of the vocab words of this unit. Now, all these vocab words, you will know they're part of the solutions unit because they all look the same. So you're like, okay, cool, that word, solution, a solution unit word, fantastic. The problem though is they all look the same. So it's very important that you distinguish between these different words. So a solution is a type of homogeneous mixture. Again, it could be elements, compounds, and there is no definite ratio by mass. So let's just say if we make lemonade, I might make it differently than how you make it, but it's still lemonade, it's still that solution. So just another fact, all homogeneous mixtures are types of solutions. Solutions can be in any phase, but generally we see them in liquids. And then in a liquid solution, light must be able to pass through it. Okay. Aqueous solutions, up to this point, you've seen it as AQ, and you know that's something dissolved in water. So if you see NaCl, which you have seen in the past, it's salt dissolved in water. Now, that's totally accurate. We're just going to add more to that. So a solution is made up of these two different things. You got your solvent and you got your solute. So here are two more words that look the same. So we've talked about solution, we've talked about solute, we've talked about solvent. Now a solvent is, they dissolve the solute. So it's something that does the dissolving and dissolving. A solute, so solvent does the dissolving, a solute is the substance that is being dissolved. So gets dissolved. Now if we look at our salt example, so we have NaCl. Our solvent is the thing that's doing the dissolving. So that would be water. Water is a very popular solvent. And our solute, again, is the thing that's being dissolved. That is the NaCl itself, or the salt. Okay. So again, here is a great picture that shows that solute, solvent, put them together, you form a solution. Now, last kind of main topic, more vocab words that are being thrown at you, is electrolytes. And so we talked about electrolytes when we talked about ionic compounds. And in electrolyte, you might see the word electron, you might see light, you might see electricity, and all those things are related. So remember, electricity is the flow of electrons. So if electrons are able to flow freely, electricity can be conducted. And so if it can conduct electricity, we call that an electrolyte when it's in its liquid form. So strong electrolytes are great conductors of electricity. Weak electrolytes are kind of weak conductors. And a non-electrolyte does not conduct electricity ever in a liquid state. Okay, and so if we think about it, let's look at our NaCl example again. When NaCl dissociates or breaks up into its ions, you have that positive sodium, you got that negative chlorine. So this negative sign is an extra electron on that chlorine ion. And so when you have all this NaCl, the dissociated ions in a beaker of water, this chlorine can kind of flow wherever it wants. And because it can flow wherever it wants, boom, you got yourself electricity. So NaCl, when it's a whole, it can move around, but there's no free-flowing electrons. When it dissociates and breaks down, that's what allows it to conduct electricity. So here we have three pictures. Here we have the light bulb is off, and if we look in at the pictures, there's no negative, there's no negative things, there's no flowing negative ions, so no current. We say that's a non-electrolyte. If we look at these two, we have a dim bulb, we have a bright bulb. So the bright bulb, we say, is a strong electrolyte. And if you look at the picture here, you have a lot of negative ions being able to be moving, a lot of these free-flowing negative ions. In the weak electrolyte, you have here's this one negative electron this one negative ion being able to move around. But the more free-flowing ions, the stronger the electrolyte. Okay, so another term that kind of looks the same is solubility. So we've talked about solutions, we've talked about solute, solvent, and now we're talking about solubility. And so textbook says the amount of solute that will dissolve in a given amount of solvent at a certain temperature. But at this point, the word solute, word solvent are new to us. So this definition means very, very, very little to us. Especially if you don't know what solute and solvent mean, you have no idea what this definition means. Just like looking at a completely different language. And so an easy definition of solubility is the amount of stuff that's able to be dissolved. So if you have high solubility, you have a lot is dissolved. If you have low solubility, you have a little bit of stuff that's able to be dissolved. And so next video we'll talk about different things that could increase the solubility or increase the amount of things that's able to be dissolved. So again, dissociation, just a few more vocab words thrown at you. We've talked about this, it's the breaking apart of an ion. So if we're looking at KCl, it breaks into K plus and Cl minus, those two ions. And we have miscible and immiscible. Miscible means it is mixable, So the two things can mix together, kind of like water and alcohol, water and lemonade powder, things that do mix. Something that is immiscible, so that I am, means it does not mix, kind of like oil and water. No matter what you do, they will not mix in with each other. And the last two words I want to throw at you today, soluble and insoluble. And we're going to spend a little bit more time on this when we talk about table F. Table F exists on your reference table. It tells you if a compound is soluble or insoluble. It's basically, soluble means it's able to be dissolved, and insoluble means it cannot be dissolved. So at this point, here is, kind of a quick review of vocab words we talked about. We talked about solution. We talked about solvent. We talked about solute. We talked about solubility. We've talked about soluble. So right now, those are five words that look very, very similar. They all start, 4 out of the 5 of them start with the first 4 letters that are the same. So again, keeping all these words separate in your head is super important. So again, in the next video, we're going to spend some time taking a closer look at Table F, solubility guidelines, which basically tells us whether or not something is soluble or if it's insoluble. So stay tuned for that. Have a wonderful